Okay, so now we come to the third and last example that we want to go through here, namely using the optional argument colClasses. colClasses is used in situations that are usually a little bit more intricate than the ones that we already covered. colClasses can be used to specify the object type that R should use to encode the column of the table that you import. And this already sounds a little bit more difficult. So just look at an example and to clarify what this is actually used for. So a typical application case is whenever you have an underlying data set where one of the column only contains numbers, but these numbers should be saved as characters, not as numbers. Why? Because then the guessing algorithm of data table fread often fails, because it looks at the column, thinks, okay, there are only numbers, so I should save it as double or integer. And I would say 90% of the cases, that's actually not a bad decision. But look at the following here. This is the raw data. Yeah? What you have here is data for Austria and Germany for 2 years, 2013-14. You have exports, probably given, I don't know, as a share or as billions or whatever, some measure for exports. And then you have a fourth column called prod code. Prod code here in this case is a product code, SITC or something like that. And the intricate thing of the product code is that it starts with 2 leading zeros. This often causes trouble. Because if you use fread using the standard default options, what this produces is the following. First 2 rows, entirely clear. Country code, character, year, encoded as integer, exports encoded as double, absolutely clear. But the fourth column, product code, here encoded as integers, because the guessing algorithm of fread looked at the column, sees only numbers, thinks, okay, maybe, or most likely, integer is the way to go here. But if we compare this row to that row, there is a big problem. I mean, integers don't have leading zeros. That's clear because they are, well, integers. Double encoded numbers also don't have leading integers. But here we have leading zeros in the product code because, for example, in the SITC product codes, there are categories where the leading zeros are important. And it is also very important that the product code has in total 4 digits. And a 2-digit product code can cause trouble. So that should have been avoided. So what you have needed to do here is to tell R not to encode this column as an integer, but to keep it as a character string. Because if you kept it as a character string, the leading zeros would have been preserved. And we can specify this column type explicitly by passing a vector into to colClasses. colClasses here would take a character vector that specifies the object types that R should use. So in our case, since we have 4 columns, we would need to provide 4 characters, each character string representing the type for the respective column. So in the first column here, C code, that we want to encode as character. Then we have 2 columns that, in our case, we want to encode as double, the year and the exports. And the fourth one, we want to again encode as character. So the column product code should be encoded as character. Often, this is a good idea to do anyways, even if it's not necessary, to make sure your code is transparent and for you to know immediately what kind of object types are relevant in this data set. But sometimes if the data set is very long, you might not want to do it. There's also an alternative approach, not using the colClasses argument, but the argument select. The argument select can be used if you want to select only a couple or a subset of columns into your data set. And then you can use a name vector to not only specify the columns that you want to read in, but also their types. You see some examples in the tutorial, and I will also give an example with regard to the final exercise. But the colClasses argument is usually the classical way of doing it. And here you can do this exercise to practice how this colClasses argument can be used. So another task would be to read in the third example file that you have downloaded in the very beginning. And this time you need to use all the arguments that you consider necessary in order to get a tibble in the end that you think actually captures the underlying raw data. In particular, here you should make sure that the column C group is stored as a factor. Hint, I touched upon this in the previous exercise. You can look at the underlying raw data by using this special functionality of RStudio. For very large files, that's not feasible, but you can use the optional argument nrows from fread to only read in a couple of rows to get an idea of how the data set looks like, or only look at a subset of columns using the select argument. But that's not absolutely essential for the data sets we're about to work with here. So main task, primary focus in this exercise is read in this example CSV and make sure the column C group is stored as a factor. And to do so, you should make use of all the optional arguments that you consider to be relevant that you have encountered so far.